Okay, hello. We're gonna look at question number 5 from the same worksheet, which was called exercises 1C, vectors. And in question 5, they give you two cars. One of them is labeled car D, the other one is car C. This is one of the cars, and the other one's this one. One of them is, they give you the location is location P. The other one's location Q, where this is at right angle to that. And this vector is the velocity vector of one of the cars, car C, which is at point P. The velocity vector has a magnitude of 30 meters per second and the direction just north or upwards. This one, car D, has a velocity of 20 meters per second and is going in that direction. And the question asks, find the velocity of C relative to D and show the relative direction in a diagram. Okay, so to answer this, first I wanted to do a brief side comment, which is, for example, this is better understood perhaps with location vectors. So for example, if this location vector here was a magnitude of 10 and this point here was A, and you're measuring from O here from the center, and that was 10, then if you imagine another point over here, for example, point B, and then there's another vector over this, right? And this was perhaps 20 in magnitude, twice as long. If somebody asks you, to give a label to these vectors, first of all, then, well, the red vector, you could just call it vector OA, like that, goes from O to A. The yellow one would be OB, right? Just gonna try to be a little bit more consistent with the colors. OB. If somebody asks you to give the position vector of B from A, so the position of B from A, and you only had these two vectors, right? One of them, the yellow one, is 20. East, let's say 20 east, and the reddish one was 10 east, and I told you, okay, so now I want one that takes me from A to B. Then the way to do that vector would be called vector A to B, like that, right? But in order to do that, what you do is you take the second one, so the vector of B, the position vector of B, and from it you subtract A, so you take the first one away from the second one. So what you're doing there would be this vector minus that one, so it would be OB minus OA. Or another way of looking at it is if vector to B was just called B, consistent with the notation B, and vector from O to A was called A, then the vector that takes you from A to B, from this one to this one, is the subtraction of B minus A. That would be the difference between these two, and it would take you from here to your final destination. So if B is 20, like here, 20 east, and A is 10, then 20 minus 10, it's still 10 in the same, positive 10 in the same direction, so that's 10 east, right? Because it's still positive. If it was negative, then it would go west, but since it's positive, it's still in the same direction as these two were at the beginning, which is to the right. So that tells you that if you start from A and you want to get to B, you need to go still to the right and another 10. Okay, so hopefully that makes sense. It's the same thing as if you have two numbers. How do you get to the number 10 and you've got another number 5? Then to know how to get from 5 to 10, you need to subtract this one from that one, so it would be 10 minus 5. So sometimes people find it strange that you subtract the first one away from the second one, but if you think about numbers, that makes sense. In terms of triangles, it's a little bit more well, it's the same, but it's a little bit more strange if you're not used to adding a lot of vectors with lines. But normally the way you add two vectors is, in this case, for example, if we were going to add those two, you have one vector like this going to the left and another vector going up. So you have two options. You can either add it here on the tail, right, and now they're both being added, and one of them is left positive and the other one is goes left and the other one goes up, and then your resultant would go from the start of the initial point to the end of the final point. So that would be your resultant if you add those two vectors. Similarly, you can add them in a different order. So when you add them, it doesn't really matter the order. You can add this one first, and then you can add the left one, and you will still get exactly the same resultant going in that direction. So this and that magnitude will be the same. You can try it out with different numbers. If this is 5 and that's this is 3 and that's 4, for example. Then this would be size 5, because 3 squared plus 4 squared is 5 squared. And similarly, if this was 3 and that was 4, this would also be 5. Okay, and this angle would be the same as that angle there, and this angle here would be the same as this angle here to the vertical. Okay. So that's just a little bit of recap about adding vectors, so you should know all of that already. And subtracting vectors is the same as that, but whichever vector you're going to subtract, you need to add it in the opposite direction. So how do we add vectors in the opposite direction? Well, in this case, instead of going well, first we need to know which one is the one that we're going to subtract, right? So that the one that we're going to subtract is the second one. So let's remember, if I'm going from O to B, if I want to know the vector going from A to B, then I need to subtract the full B. I need to subtract from it the smaller a, if I want to go from A to B. So here they're asking us for the resultant velocity of C relative to D. So we want to know how this one, C, is moving relative to D. So in other words, we want to have the vector that tells us how to go from D to C. Okay, hopefully that makes sense. If they tell us what's the velocity of this one relative to that, then this is the starting point, and we want to know the vector that points to that velocity always. So if we want to go from D to C, D is the subtracting vector. It's the one, like here we want to go from A to B, and so A was the one that we were subtracting away from B. Here's the same, we want to go from D to C, so the subtracting vector then is going to be the 20 away from the 30. So that means that we start with the 30, that's our 30 that we start with, and now we're going to add, to subtract this one here, 20. How do we do that? Well, if we added it, we would be adding it here on the tail, would be adding it here to the left. But since we're not adding it, what we do is we just do we flip it around and we do the exact opposite. So now that's what we do, we take it in the other direction in such a way that when you add these two, you get a resultant that crosses them like this, and this is what you're being asked for, that resultant. And the question says to draw a diagram. It says find the velocity of C relative to D and show the relative direction in a diagram. So here's a relative direction. We can even calculate the angle theta if we want, and we're asked for the resultant. So another way of thinking about this is that imagine that you're in this car moving along, then your position vector as you move along, your velocity, the velocity that describes how this guy is moving with respect to you. It's going to be moving kind of, imagine that you're in this car window and looking at this one go that way. He's moving kind of that way and to the right, like that, to the right. So it looks like relative to you, if you're moving in this direction, relative to you, this guy is moving to the right, and I don't know if you can see that. Anyway, hopefully that helps a little bit to imagine it. So let's see, so what's the magnitudes here? So this one is 30 and this one was 20 meters per second. So the resultant squared is going to be equal to 30 squared plus 20 squared, which then if we take the square root of r, it comes out as 36 meters per second for the resultant. So that's the relative velocity of c with respect to car D. And for the angle, if we wanted to know the exact angle, this is towards east away from north. If we wanted to know the exact angle, we just do opposite and adjacent, so that's TOA. So that's tan of theta is equal to opposite divided by adjacent. And then if we do the inverse tan of that, then the inverse tan comes out to be 33.7 degrees east of north. Okay, so hopefully that helps with relative velocities. Whenever you want to know the vector from one to the other, if they tell you that you want to go from A to B, then it's always the vector that describes B, whatever vector that is. It could be called OB or just B or whatever, and you gotta subtract from that the vector that gets you to the point where you're starting. So how to go from there to there? You do the second minus the first vector. Okay, hopefully that makes sense. See you in the next video.